Okay, in example 3, we're told that the sine of pi over 2 minus x is equal to 2/3. And anytime you see 90 degrees minus x or pi over 2, which is radian equivalent for 90 degrees minus x, that should be a big red flag to use a cofunction identity. So if you recall, the cofunctions go across. So the cofunction of sine is cosine, the cofunction of tangent is cotangent, cofunction of secant is cosecant. That's why they all have co in the front of them. So the cofunction of sine is cosine. That means that if I shift pi over 2, I know that it's equivalent. So the cosine of x is equal to 2/3. Right, and I get that from my cofunction identity. Okay, then I can put that on my hexagon. And I could use a reciprocal identity to get the secant, because those go through the center here. So the reciprocal of 2/3 is 3 over 2. So that would be the value of the secant. And then, let's see, we're too far away to use a product or quotient identity, so we're going to need to use a Pythagorean identity. Since we're already up here with cosine, we may as well just finish out that triangle, because remember, your Pythagorean identities make these triangles. So the sine squared plus the cosine squared is equal to 1. That's my Pythagorean identity. So sine squared x plus cosine squared x is equal to 1 squared, which is 1. Then we'll substitute in the cosine value that we know. So the sine squared x plus 2/3, that quantity is squared, is equal to 1. And when we square 2/3, we get 4/9. We're going to go ahead and subtract that to the other side to isolate this sign. So sine squared x is equal to 1 minus 4/9. And we need a common denominator in order to subtract fractions. So we'll change that 1 to a 9 over 9. And then the sine squared x is equal to 5 over 9. We'll square root both sides, and sine of x then is plus or minus square root of 5 over the square root of 9, which is 3. To know whether that is the positive or the negative that we keep, we got to figure out which quadrant we're in. So if we sketch out the unit circle, and then we put our acronym, all students take calculus. Remember, the A stands for all. All 6 trig functions are positive in quadrant 1. The S is sine and its reciprocal. Those are positive in quadrant 2. Then in quadrant 3, tangent is positive and its reciprocal cotangent. Quadrant 4, cosine and its reciprocal. Those are positive in quadrant 4. So we're told that the sine function is, let's see up here. Oh, sine function is positive. Tangent is also positive. So that means we have to be in quadrant 1. So all of our trig functions the whole way around are going to be positive answers. So the sine of x then is positive square root of 5 over 3. Okay, and that's our value for sine. Okay, now we're going to look for another one, and we could find the tangent by using a product identity, since those are the vertices to the left and right. So if we use that product identity, then the tangent of x is equal to the sine of x times the secant of x. Sine is the square root of 5 over 3. Secant is 3 over 2. Our 3's cancel, and that leaves square root of 5 over 2 for the tangent. Square root of 5 over 2. Okay, now to get the, let's see, the reciprocal there, the tangent, the reciprocal, which is cotangent, we could use 2 over square root of 5. That's the reciprocal of the tangent. Then we'll rationalize that denominator, and we'll have 2 square root of 5 over 5. Okay, and there's a cotangent. Then cosecant, we can use the product identity. If you want, you could use the reciprocal identity or even a quotient. I'm going to go ahead and do the reciprocal. So 3 over square root of 5. And then we rationalize that denominator. And we have 3 square root of 5 over 5 for the cosecant. And then we've got all 6 evaluated.